Number 15 is where I'm starting here. And I just want to tell you, if you hear a weird rhythmic noise, it is my ceiling fan. It's something to do with the remote control, but it's making a peculiar sound. But it is so hot today that I'm just really needing the fan. So I hope it's not too distracting, and I wanted you to know what it was. Number 15. An auditorium has a seating capacity of 1,500. For an upcoming community theater play, tickets cost $4 for adults and $2 for children. At last year's play, twice as many children attended as did adults. If the attendance at this year's play has the same ratio, which of the following expressions represents the best estimate of the total amount of money from ticket sales when the auditorium is filled to capacity? I would not consider this an easy problem. I guess it depends on how you look at it. The test considers this easy, so the point weight for this one would not be as heavy as some others. Let me see if I can first just help you see the common sense way, and then I will do it the algebra way so that you can see both of them and you can decide what you want to do. The first thing I would do is figure out what they're asking me to find. And they want us to estimate the total amount of money from ticket sales if that auditorium is sold out. So we know that our answer must include something to do with money. And unfortunately, all of them do. So that little trick would not help me. The next thing I would want to notice is that tickets for adults are $4 and tickets for children are $2. So the money for adults is more than the money for children, which I would expect. So we can eliminate one of our answers right here. Actually, we can eliminate two of them because we are looking at adults and children attending the play. So if all the audience were adults, maybe if this were a play that only adults could attend, this would be the way to find the ticket sales. Maybe if the children got in free and the adults had to pay $4 each, A would be the option for all adults. B would be the option for all children. So maybe, I've never heard of this before, but maybe if you pay for a children's ticket, the adult gets in free. Never heard that. That's not the case in this story. So we can eliminate A and B. And if I just had to guess, I would go with C, D, or E. All right, let's take a look at C and see if this could be a possible answer. But I do need to highlight a little more of my problem. It says that twice as many children attended as did adults. So we know that more kids were in attendance than adults. And so that will help me rule out C. Because if C were the case, that's telling me that we have the same amount of children and adults. And the story specifically told us that we have twice as many kids than adults. So C could not be the answer. All right. We can figure this out from here using that piece of information. If there are more kids than adults, now let's look at this. Remember, the adults are $4 and the kids are $2. So D is not the answer because it's saying that there are 1,000 adults and only 500 kids, when we know that the opposite's true. There would be double the number of kids than there would be the adults. So D is not the option. That leaves us with E. And I guess if you do it this way, it could be considered easier. I still would not call this easy. Even at this method, I would call it a medium. But let me show you the algebra way for those of you who may want to know. If you don't want to know, just stop this video right now and move on. The answer is E as in echo. But for those who do want to know, I'm going to come down here where I have some space. So here's what the story tells me. Actually, let me start with what I know to be true. I know that both adults and kids are going to attend this program, and that together they can take up as many as 1,500 seats. And we want to know the dollar amount. So this statement alone will not really help me immediately. But I do know that the adults and the kids sold out would be 1,500 seats. I know that each adult ticket costs $4, so I'm going to say the adults are $4 times A. And the kids are $2 for every kid. And that together, that would equal the total amount of money. That's not 1,500 because 1,500 is the number of seats. And the seats cost different amounts. They also tell me that for every one adult, there are twice as many kids. So for every one adult, it would be the same as having two adults, total of 3 people in terms of seats. So we know that those represent seats. And so I'm going to work with this equation for just a second. This is where I need to start. So I'm going to combine the A's to get a total of 3A, and that would equal 1,500 seats. And if I divide both sides by 3, that tells me that the adults are 500. So adults would take up 500 seats, and that means the kids would take up double that, or 1,000 seats, and that's my 1,500 seats. That combination right there makes up 1,500 seats. So then we have to introduce the dollar values. And I know that the adults are $4 and that there are adults in 500 seats. And then the kids are $2 and there are children in 1,000 of the seats. And that is essentially what we're saying in E as in echo. So if you work it with algebra, you will still get the same answer. If you work it with just common sense reasoning, you will still get the same answer. Just depends on how you want to do it. I did it with this, and I thought I would not call that an easy question. But then as I started to talk to you out loud, I began to see how it could be easier. I won't say it's easy, but it could be easier to just reason your way through it. But either way, the answer is E as in echo.